Hi guys, so in this video we're going to be using the unit circle to evaluate some trigonometric values that you need to know from memory in the paper 2 exam of CIM, because that's a non-calculated paper and these are some of the core angles that you need to know. So some of the other angles you won't need to know are like sine or cosine of 17 or something like that, but for 0, 30 degrees, 45 degrees, 60 degrees, and 90 degrees, you will need to know how to use the unit circle or just know these values from heart. And you may be using them in a variety of calculations. So in your paper 2 exam, you won't be given a calculator, so you have to know these values. I just think it's better if you use the unit circle to explain how these values are found, because it might help the understanding better. So the unit circle, as it sounds, is basically just a circle with a unitary radius, just 1 unit long. And as you can see, I've drawn the radius, the unit 1. But there are triangles in these circles that you can then use to help find different values for different angles. So if I were to draw a triangle from this point, let's say this angle in between this triangle is theta. So we know the hypotenuse is 1. And let me just write down here, sine of x or sine of theta, let me just write theta actually, is equal to opposite over hypotenuse. Cos of theta is equal to adjacent over hypotenuse, and tan of theta is equal to the opposite over the adjacent. So if I consider this, let's say this is x, the number of units to the right, and then y is the number of units up. So in this case, sine of theta is equal to the opposite, which is y, divided by the hypotenuse, which remains 1, as we can see, because it's the radius in this case. So we're given that sine of theta is just equal to y. So we know that cos of theta is adjacent over hypotenuse, which is x, which is our adjacent, over 1, which is x. And then tan of theta, we're given as opposite over adjacent, so the opposite is y, and the adjacent is x, so tan of theta is y over x. Now I just want to focus on sine and cosine for a second. We know that sine theta is y and cos theta is x. So the coordinates of this point over here, that I've drawn an x on, is cos theta, sine theta. And this is really important. So now we're going to move on to when we have these critical angles. So let's say that, I'm just going to erase this over here. So let's say that theta is equal to 0. Well, in this case, okay, so I want you to remember that the hypotenuse is always going to be 1 because it's just moving. So let's say the hypotenuse is just moving around the circle in a 360-degree loop. What about when it starts at 0? It's just a flat line, basically. The hypotenuse is 1, but the y value is 0 because there's no vertical height. And the x value will also be 1 because on the unit circle, it will be a vertical line extending all the way to the edge of the circle. Given that we know this, we know that sine is opposite over hypotenuse. So given that, we know that the opposite is 0 and the hypotenuse is 1. But 0 over 1 is just 0. So sine of 0 is 0. For cosine, we know that it's adjacent over hypotenuse. The adjacent is 1 because x is 1. And the hypotenuse is always 1, so it's 1 over 1, which is 1. We'll come to tangent a bit later. Let's just focus on sine and cos. So now we're going to move on to sine 30 and cos 30. So actually for these 3 angles over here, I have 2 separate triangles that I recommend remembering because these will help you derive sine 30 and cos 30 and sine 45 and cos 45 and 60 and all that. So the first triangle helps you with finding 30 degrees and 60 degrees. So it looks a bit like an equilateral triangle. Let's say they have side length 2. But you have a line down the middle dividing it in half. So that means that since it's divided in half, one side length and one side length. And if we use Pythagorean, we get what x is, the height of the triangle. X is equal to the square root of 2 squared minus 1 squared, if we use Pythagorean, which is equal to root 3. So therefore, we also know that x which is our height of our triangle, is root 3. Given that we know this, we can take this angle over here. We know that theta in this case is 60 degrees because we have an equilateral triangle. And then this one over here is just the equilateral triangle's angle has been halved, so it's 30 degrees. And now we can use this to find sine and cosine of 30 and 60. So sine of 30 is, I'm just going to enlarge this triangle. So if you put the triangle on its side, where this is 30 degrees, just basically rotate it, then we have the opposite is 1, and the hypotenuse is 2. We know that the adjacent is root 3. So that means sine of 30 is opposite over hypotenuse, which is 1 over 2, so half. Cosine is adjacent over hypotenuse, so it's root 3 over 2. And then for 60 degrees, which is over here, so the opposite is now root 3, and the hypotenuse remains 2, but the adjacent's now 1. So sine of 60 would be opposite, which is root 3 over 2. And cosine of 60 is adjacent, which is 1 over 2. Oops, I put them in the wrong box. Let me just move them. Root 3 over 2, 1 over 2. All right, and now I'm going to draw the 45-degree triangle. So the other triangle you can remember is this over here, which has 45 degrees angles, and it's another right angle triangle. So the best way to do it is just using right angle triangles for this. So let's say these both have side length 1, since it's an isosceles triangle. Then this would have a hypotenuse of root 2, based on Pythagorean, root 1 squared plus 1 squared, which is just root 2. So for 45, sine and cosine are both equal because the adjacent and hypotenuse are adjacent and opposite are both equal, and that's the only thing differentiates sine and cosine. So we can just do this together. So the opposite of 45, or the adjacent, is 1, and the hypotenuse is root 2. So it's 1 over root 2. However, if we rationalize the denominator, we can get that this is root 2 over root 2 times root 2, which is 2. So root 2 over 2. So sine 45 is root 2 over 2, but cos 45 is also root 2 over 2. And then we have sine 90 and cos 90. So 90 degrees is when the hypotenuse has reached this marker over here, which represents 90 degrees, and it's completely vertical as well. So what we need to consider is the hypotenuse is obviously always 1. The opposite, which is basically the height, is going to also be 1 because it's completely vertical. But the adjacent this time, this is lined up with the origin. There is this length over here would be 0 if it's a vertical line. So given that sine is opposite over hypotenuse, we've got O over H is 1 over 1, which is just 1. Cosine is adjacent over hypotenuse, which is 0 over 1, so that's 0. Now, the reason I've left out tan is because I wanted to point out a particular thing. Since sine is opposite over hypotenuse and cosine is adjacent over hypotenuse, we can actually say that tangent is equal to sine over cosine, because sine over cosine is O over H divided by A over H, which just evens out to O over A, which is the identity for tangent. So this is something that's really important to consider. We can find tangent of these values using just the triangles that were given, but let's do it using sine over cosine. So in this case, tan of 0 is sine over cos, and since sine is 0, 0 divided by anything except for 0 is going to be 0. So we're given that tan is 0 at 0 degrees. At 30 degrees, tangent is equal to half over root 3 over 2, which is equal to 1 over root 3, which is equal to root 3 over 3 when rationalized. Now, moving on to 45. So tan 45 is root 2 over 2 divided by root 2 over 2. So you're dividing the same thing by itself. So it's going to just be 1. Then you've got tan 60, which is root 3 over 2 divided by half, which is just equal to root 3. And finally, we have tan 90. Now, In tan 90, we're doing 1 over 0, which is undefined. So for tan 90, there is no value, undefined. And therefore, whenever we get a tan 90 result, the final answer cannot actually be calculated. It's not possible to have tan 90. So those are the core angles you need to know. And the other thing I was going to go into now is how it works in other quadrants. So all it explained is how it works in the first quadrant, where everything is positive. However, in other quadrants, you may get negative values because of the coordinates. So let's say you have in the second quadrant. In the second quadrant, we know that the x value, x will be negative because it's going to the left now. However, the y value, which is the amount it goes up by, will remain positive because you're going up in quadrant 2. Based on this, we can make deductions about sine and cosine. They'll hold the exact same values as mentioned in this table. However, they will either be negated or the same. So in this case, we know that sine is basically y. And since y is positive, sine is unchanged. Cosine is adjacent over hypotenuse, or the x value, and the x value is negative, so cosine is negative. Tangent is sine over cosine, and since sine over cos is a positive value divided by a negative value, tangent will also be negative. So in quadrant 2, sine is the only one that is positive. Let me write that down. Sine equals positive. Now let's consider the next quadrant. Let's consider quadrant 3. In quadrant 3, everything, all the coordinates are negative. So we're given that the x value is negative, the y value is negative. So that means that x, which is represented by cosine is negative. Y, which is represented by sine, is also negative. But tangent is sine divided by cosine, and since it's a negative divided by negative, it creates a positive value. So tangent is the only one that is positive here. And now we're on to the final quadrant, quadrant 4. In quadrant 4, we have that, let me just erase the bottom part. We have in quadrant 4 that x is positive and y is negative, because the y value is going down this time, but the x value is still going to the right. So we know that cosine, which is represented by x, is positive. Sine, which is represented by y, is negative. And again, tangent is negative divided by positive, so that's negative. So cosine is positive. Over here, you can see that apart from the first quadrant, only one is positive in the other quadrants. There is a way of remembering which one is where, because you don't want to have to keep doing this process to remember. Where you have this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. It's, A, S, T, and C, where C is cosine, A is all of them, S is sine, and T is tangent. You can remember it as cast, C-A-S-T, to remember it. So cosine's positive in the fourth quadrant. All of them are positive in the first quadrant. Sine is positive in the second quadrant, and tan is positive in the third quadrant. And remembering this will be helpful because the angles still remain the same. And what I mean by that is when you take the circle, oh wait, let me just use this one. I'll just erase. So if you drew the same triangle except reflected across the y-axis, if you're finding sine, that would be the same value. But if you're finding cosine, then the value would be negative, and same for tangent. This angle, which has the same interior angle as this one over here, is actually 180 minus that, because it's this angle over here. So that would be 90 plus whatever this is, plus 90 minus whatever this is. So what I mean by that is that even though you have a triangle like this, the angle is actually all the way until 0 degrees. So that's 135 degrees. you go anti-clockwise. So given that this is 135 degrees, we can say that sine of 135 is equal to sine of 45. And cosine of 135 is the negative version of cosine of 45, etc. Now the same can be said true if it's reflected in the x-axis. So we have over here that 180 plus whatever this critical angle is here over here, because essentially this over here is 180 degrees, is the same for tangent and negative for the others. So for example, tan of 45 is the same as tangent of 180 plus 45, which is 225. However, sine of 45 is the negative version of sine of 225. And cosine of 45 is the negative version of cosine of 225. So you have to be able to transfer these across quadrants. Now, of course, this part over here is also a thing that you have to be aware of. So if you have the same critical angle over here, you just do 360 minus the critical angle. And the critical angle, by the way, is denoted by this first column over here, 0, 30, 45, 60, 90. So for example, sine of 60 is equal to sine of 360 minus 60, which is sine of 300. Except it's negated because it's not positive in that quadrant. Cosine of 60 is equal to cosine of 300 because it's positive in that quadrant. And tan of 60 is equal to negative version of tan of 300, etc. So you just have to keep this in mind, this whole reflection across each of the axes, in order to derive how the critical angle may be applied to different quadrants. And the negative sign is very important. Anyway, I hope this introduction to the unit circle was useful, and that now you'll be able to figure out how to find the critical angles of 0, 30, 45, 60, and 90 degrees of sine, cosine, of tangent, and tangent. Thanks so much for watching this video, and see you in the next one.